Assalamu alaikum. Welcome to this MATLAB tutorial. Today I am going to teach you how to perform optimal power flow using the MATLAB programming. Friends, before going to start, I want to mention here that optimal power flow topic is very important in the field of power system. This topic can be used to complete the bachelor degree final year project, master research as well as for PhD research. At this stage, question may arise that what is the difference between economic load dispatch and optimal power flow. Economic load dispatch calculates how much power is produced at each power generator ignoring the transmission network, whereas optimal power flow combines the load flow analysis and economic load dispatch. In short, the economic load dispatch is not considering the real power losses due to which it may not provide the optimum economical scheduling of the power plants. On the other hand, in optimal power flow, the loss coefficients or losses are obtained first by performing the load flow analysis in order to obtain the minimum losses so that cheapest overall generating cost may be obtained. In order to teach you the optimal power flow using MATLAB, I have taken an example from the book Power System Analysis by Hadi Sadat, Chapter 7, Example 7.10. Consider the example which consists of 5-bus power system having generators at bus 1, 2 and 3. The bus voltages and other data is given as shown in the figure. The generation cost function of 3 power plants are given in the following equations, where P1, P2 and P3 are the power supplied by 3 power plants in megawatt. We have to find the optimal dispatch of generation, total cost and losses when the generators have following real power limits. Furthermore, it is asked that continue the optimization process until the difference between the scheduled slack generation determined from the coordination equation and the slack generation obtained from the power flow solution is within 0.001 megawatt. Now I am going to perform the optimal power flow in MATLAB. However, before going to start, I want to highlight again that for the solution of optimal power flow, Hadi Sadat has already made the built-in functions. Therefore, for the convenience, you must have MATLAB folders of Hadi Sadat book. On this topic, I have already made the video on how to save MATLAB folders of Power System Analysis book by Hadi Sadat in MATLAB using the set path feature. I would strongly recommend to watch this video first for better understanding of this topic. It is because we will directly call the MATLAB functions from the MATLAB folders of Hadi Sadat book. Let's start. At the first stage, we need to open the Hadi Sadat MATLAB folder in the current folder section. As you may see, this example is already written in MATLAB programming by Hadi Sadat. Therefore, just double click on it to open this program. Now I am going to explain how this program is written. It may be noted that to perform the optimal power flow in MATLAB, 3 variables are defined, namely base MVA, power mismatch accuracy and maximum number of iterations. The values for these variables are set by default. However, you can change these values depending upon the need of the problem. Now we are going to put the values from the example data. At the first stage, we have to put the bus data. For this purpose, just look at the figure. It may be seen that power system consists of 5 buses. The bus 1 is considered as the slack bus. It has the voltage magnitude of 1.06 per unit with 0 degree. Now look at the bus data in MATLAB program. The first entry is bus number, which is written 1 to represent the bus 1. Bus code is also written 1. According to Hadi Sadat, bus code 1 is always written to mention the slack bus in the MATLAB program. After that, bus voltage 1.06 and angle 0 degree are written. Rest of the entries are 0, only reactive power minimum and maximum limits are mentioned as 10 and 50 MVAR respectively. Look at the figure again. It may be noted that bus 2 is working as PV bus. It has the voltage magnitude of 1.045 per unit with angle 0 degree. Furthermore, it is supplying 40 megawatt of active power to the system, whereas this bus has a load of 20 megawatt and 10 MVAR. Therefore, look at the second line showing the data for bus 2. It may be noted that according to Hadi Sadat, bus code 2 is always written to mention the PV bus in the MATLAB program. Therefore, bus code written here is 2. Rest of the entries are same as mentioned in the example data. Look at the figure again. It may be noted that bus 3 is also working as PV bus. It has the voltage magnitude of 1.03 per unit with angle 0 degree. Furthermore, it is supplying 30 megawatt of active power to the system, whereas this bus has a load of 20 megawatt and 15 MVAR. Therefore, look at the third line showing the data for bus 3. It may be noted that bus code 2 is written here again to mention the PV bus. Rest of the entries are same as mentioned in the example data. Look at the figure again. It may be noted that bus 4 is working as load bus having the load of 50 megawatt and 30 MVAR. Therefore, look at the fourth line showing the data for bus 4. It may be noted that according to Hadi Sadat, bus code 0 is always written to mention the load bus in the MATLAB program. Therefore, bus code written here is 0. The voltage magnitude and angle for load bus is always considered as 1 per unit and 0 degree respectively. Rest of the entries are same as mentioned in the example data. Similarly, look at the figure again. It may be noted that bus 5 is working as load bus having the load of 60 megawatt and 40 MVAR. Therefore, look at the fifth line showing the data for bus 5. It may be noted that bus code 0 is written here again to mention the load bus. Rest of the entries are same as mentioned in the example data. At this stage, we have successfully inserted the bus data of the example. Now we need to insert the line data of the example. In the line data, we need the resistance, reactance and capacitive susceptance of the transmission lines. For this purpose, just look at the figure again. The transmission line from bus 1 to bus 2 has the resistance of 0.02, reactance of 0.06 and capacitive susceptance of 0.03 respectively. Therefore, look at the first line of the line data showing the data for the transmission line 1 and 2. You can see resistance, reactance and susceptance are written correctly. The last column is for the transformer tape setting for the lines. If line has any tape setting, then we have to put that value. Otherwise, 1 must be entered in this column. Therefore, 1 is written here. Friends, in order to save the time, it is not necessary to show you the line data of each transmission line because it is very easy process. You may repeat the same procedure to put the values for all the transmission lines. Now look at the example data again. The cost function variables for all 3 power plants are shown in these equations. Therefore, to write this data, the program has introduced an array namely cost and has put all the cost function variables in the matrix form. Look at the example data again. This time the maximum and minimum real power limits of all power plants are given. Therefore, this program has introduced another array namely megawatt limits and has put all the minimum and maximum limits here. Now, in order to obtain the transmission system losses, we need to run the load flow analysis. For the load flow analysis, the first requirement is to obtain the admittance matrix. Therefore, to obtain the admittance matrix, this program has used built-in function namely LFYBus to calculate its admittance matrix. Let me show you the built-in function of LFYBus here. Just double click on it to open it. This shows the LFYBus MATLAB function program. Now the next step is to calculate the load flow analysis. For this purpose, this program has used a Newton-Raphson load flow method. Therefore, built-in function of Newton-Raphson load flow method is called by writing here LF Newton. Let me show you the built-in function of LF Newton here. Just double click on it to open it. This shows the LF Newton MATLAB function program. Now in order to display the output result of the Newton-Raphson load flow method, another built-in function namely busout is used here. Let me show you the built-in function of busout here. Just double click on it to open it. This shows the busout MATLAB function program. As already mentioned that load flow analysis is used to calculate the transmission line losses, are commonly known as loss coefficients. Therefore, to obtain the loss coefficients, this program has used again built-in function namely BLOSS here. Let me show you the built-in function of BLOSS here. Just double click on it to open it. This shows BLOSS MATLAB function program. Now we have to call the built-in MATLAB function namely GenCost in order to obtain the total economical generation cost. Therefore, in this program GenCost is written here. Let me show you again the built-in function of GenCost here. Just double click on it to open it. This shows the GenCost MATLAB function program. Now we have to call the built-in MATLAB function namely dispatch in order to obtain the optimal dispatch of all power plants. Therefore, in this program dispatch is written here. Friends, at this stage our program is almost complete. However, in order to obtain the accuracy up to 0.001 as required in the example, we need to calculate the difference between scheduled slack bus generation power from the coordination equation and the load flow analysis. Therefore, we have used here while loop, in which stop criteria for the loop is selected as 0.001. Now this loop will calculate the difference and will compare it with the threshold. The process will continue until the desired response is obtained. In the end, to display the load flow and final total cost, busout and GenCost is written again here in this program. This is the whole program of optimal power flow. This program has the beauty that this program can be used as it is for any kind of power system problems. Only we have to change the bus data and line data in the program. Now let's run the program by clicking on this button. You can see MATLAB has calculated the optimal power flow, incremental cost, optimal dispatch and total cost for the given example. Look at the results. It can be noted that initially the load flow converges within 3 iterations. The initial transmission loss coefficients obtained are shown here. Due to these loss coefficients, power system has losses of 3.05248 megawatt. In these conditions, the total generation cost and optimal dispatch is shown here. However, you may notice that the difference between the scheduled slack bus power through load flow analysis and coordinated equations is 0.4996. This shows that still our results are not optimal. Therefore, in order to find the optimal results, the program has done several other iterations and has found the optimal results as below with the dp slack equal to 0.009. At this stage, you can see transmission line losses are reduced from 3.05248 megawatts to 2.15691 megawatt. Due to these, the incremental cost is also reduced. The final optimal dispatch of 3 power plants are shown here. With this optimal dispatch, the total generation cost is now $1,596.96 per hour. Let's compare the total generation cost for this power system. It may be noted that the total generation cost for the initial operating condition is $1,633.24 per hour, whereas the total generation cost with the optimal dispatch of generation is $1,596.96 per hour. This results in a saving of $36.27 per hour. Now if we want to calculate this saving for the whole day, then this saving will be $870.48 per day, whereas for 1 month this saving will be $26,114.4, whereas for 1 year this saving will be $3,13,372.8. Friends, from these calculations you may now fully clear about the importance of this topic. Now you may understood why optimal power flow and economic load dispatch analysis is important in the field of power system. To elaborate it further, Hadi Sadat has given another example, namely 7.11, consisting of 26 bus power system. The optimal power flow solution of this system has resulted in saving of $1,313.01 per hour. It means that with this loading, the total annual saving is over $11 million. It means that saving in dollars is dependent upon the size of the power system. Therefore, it is necessary to perform the economic load dispatch and optimal power flow in order to make it economical. Friends, by doing the same way, economic load dispatch and optimal power flow of any power system from small to large size can be performed. I will strongly recommend all of you to take IEEE 9 bus stage system data, IEEE 14 bus stage system data, IEEE 30 bus stage system data, IEEE 69 bus stage system data, and so on. Performing the economic load dispatch of these IEEE systems can be used as an objective for your bachelor degree final year project, as well as one of the research objective of your master and PhD degree research. That's all for today's tutorial. I hope you really enjoyed this tutorial. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.